Five lines J, K, L, M, and N in the coordinate plane are shown in the diagram. The slopes of the 5 lines are in the table below. Complete the table, matching the lines to their slopes. Just to remind you of the meaning of the slope of a line, let's look at this line K. If we pick any point on the line and increase x by 1, okay, we always draw a horizontal line of length 1. Then what we do is we complete a triangle by drawing from this point up to meet the line, or down to meet the line. Well, in this case we have to draw up to meet the line. Since we have to draw up to meet the line, it means that this line has a positive slope. So as x increases, y increases basically. By increasing x, I mean that if you imagine walking from left to right along the x-axis, does the line appear to go up or go down? Okay, so we're always walking from left to right along our x-axis. You can see that the line actually goes up, and the amount that it goes up by is the slope. That number is positive. Now we have a couple of values here, so we want to consider what this length is. It's going to be positive, so it's not going to, so it's not either of these two values. It's not 0 either, that's for sure. Is it 1/8 or 2? It can only be one of these. As a matter of fact, it's 2. Now, how do I know it's 2 instead of 1/8? Well, both of these are positive slopes anyway, so it has to be one of these. So it's a 50-50 chance that you guess that the answer is line K. But if we look at the other line which has positive slope, it's actually line M. If we pick any point on line M and increase x by 1, then y actually increases by a certain amount. M has a positive slope, but the amount that y increases by is less than 1. You can see that M has a lower slope than K has, but it's positive. Put the plus signs in here to emphasize that both lines K and M have positive slope. So they're the two lines of positive slope. Now there's a line with a slope of 0. Well, that's a horizontal line. That's this line here, L. Like if we pick any point on L and increase x by 1, then you see that to get back onto the line, we have to go up or down 0. So we don't even have a triangle here. So the amount that we increase x or y by is 0. Now the two remaining lines have negative slopes. You can see they're sloping down in this direction, negative slope. Like for example, if we look at line N, pick any point on it and increase x by 1. So we moved to the right a distance of 1. Then you see we have to go down to meet the line. So that means the line has negative slope. And the amount that we go down by is the slope. The same is true for line J. If we pick any point on line J and increase x by 1, then the amount that we go down by is the slope. So you can see that for line N we have to go down more to meet the line than we do for line J. So N is the line that has a slope of -1. We have to go down a distance of 1. Whereas for line J, we only have to go down a distance of 1/4. See, this vertical distance here is less than this vertical distance here. I've only marked in these distances. So I've only written down the positive value, but of course the slope of this line is -1, and the slope of line J is -1/4. You are probably more used to working with this formula here. We can't use this formula here when we're discussing the slopes of these lines because we don't have 2 points on any of these lines. Let's look at line K. Let's suppose we knew the coordinates of this point and this point here. Then if we put those values into this formula here, we would get an answer of 2. So this point down here might be x1, y1, whatever it is, and this point up here is x2, y2. If we knew both of these points, we could calculate y2 minus y1 over x2 minus x1. We would see that y2 minus y1 would be 2, and x2 minus x1 would come out to be 1. we'd end up getting plus 2 over 1. We get an answer of plus 2. If we knew the coordinates of these 2 points here and applied our formula, we would end up getting minus a quarter. That's for this line J, and so on. The diagram shows 4 circles of equal radius. The circles are touching as shown. The equation of C1 is x squared plus y squared equals 9. The center of any circle in the plane is denoted by HK. The radius is denoted by the letter R. XY is any point on the circle. Now, by Pythagoras' theorem, we can show, and I've shown it in another video, that x minus h squared plus y minus k squared equals r squared. This should remind you of Pythagoras' theorem. The sum of the squares of the 2 short sides of a right angled triangle is equal to the square of the hypotenuse of the right angled triangle. The triangle in question here is this one. So r is the hypotenuse, and these are the 2 short sides of the right angled triangle. Anyway, that's just an aside. We really need to look at this formula and consider what happens when both h and k are 0. So if we want to consider a circle that's centered at the origin, then we just plug 0 in for h and 0 in for k. And let's suppose the radius of the circle is r. Could be anything. Well, this just simplifies down to x squared plus y squared equals r squared. So here's an important form that you should keep in mind. This is a circle centered at the origin with a radius of r. Because x minus 0 is just x and y minus 0 is just y. Well, this is really the key formula. Everything is built on this formula here. So starting from this, you can quickly show that a circle centered at the origin has this simpler form. So the circle C1 in the question is x squared plus y squared equals 9. So now we know that this number here is the radius squared. So if the radius squared is 9, that means the radius must be equal to 3. The square root of 9 is 3. So now we can get a better understanding of this diagram. If the radius of C1 is 3, it means that this point here is 3. And this point here must have coordinates 6, 0. So this is 3, this is 3. 3 and 3 is 6. To get the coordinates of the center of C3, we need to get this distance here. Well, we know the radius of C2 is 3, and the radius of C3 is also 3, because all 4 circles have the same radius. So the distance from here up to here is 6. So the y value of this point is 6. What's the x value? Well, the x value of this point is the same as the x value of this point here, which is 6. So the coordinates of the center of C3 must be 6, 6. Now we want the equation of C3. Well, the center of it is hk, h, k. So h is 6 and k is 6. The radius of it is 3. So we use this formula here. We replace h with 6, k with 6, and r with 3, and we get x minus 6 squared plus y minus 6 squared equals 9.